Okay, so this is a lesson on how to approach domain problems, like the ones in Chapter 2. I'm going to start by looking at this example. This is one of the problems. And so what I do with these is one of the things that I look for right away is, some of the rules of math that might be violated. Like you can't divide by 0, right, in math. So if we wanted to make this denominator be 0, we would set x to 4, right? So if I say, let's just print out m of 4, it comes right back and says 0 division error, float division by 0. Okay, so that one's pretty clear that we can't have an x in the domain. Okay, that doesn't define the whole domain, but it kind of it tells us what we can't have in it. Okay, another example of that would be, let me make sure I've imported math here. If we said print math, because I want to do the square root of like -32. Okay, so we're taught, at least with the real numbers, that we can't take the square root of a negative number, and in Python it's the same thing. We get an error right here. It says value error, math domain error. Okay, so that's nice. It's telling you explicitly we have a domain problem. So we can't have a negative number in the domain here for the square root. And actually, this one is pretty obvious, right? If you take the square root of something, anything that's 0 or bigger, you can take the square root of it, right? And for this one, it's pretty clear too. You can divide any two numbers as long as the denominator here isn't 0. So really, this one's pretty clear too. The domain is any number that's not 0. So you could have any float or anything you want. And the same thing here, any number that's 0 or bigger. And this is any number that's not 4. Okay? So that's one thing I look at. And then another thing I look at is, so another thing I look at is you can actually throw in a test. If you have a problem like this one, so here this m won't work for x equal to 4. Well, another one of the examples is this guy, n. And what they did was they said, well, I know that I'm going to run into trouble if I have x equal to 4, so let me put in a test, and I'll return a value in that case. So here I can say print n of 4 because it'll just return the 0. So it goes through and does this before it even tries to do this business down here. Okay. But tests can also run you into trouble with the domain, right? So here's an example following that one, where we have if x is greater than 2, return x plus 2. That's fine, but what happens if x is not greater than 2? There's no so what if x is 1? What happens? You get none back. Okay, so in some ways, it depends on how you look at it for this one, I guess. It didn't give you an error, right? It did return a value. But really what we're looking for is we want to get a number back. Okay, if you're writing for the functions that we're writing, we generally, except like, the tab function or, the test function, something like that, we generally are looking for a number back, okay? So if you put in, and in all cases you get a number back except, in a certain range of inputs, then, the way I would look at this is, anything equal to or less than 2 is outside of the domain. So print 2 doesn't work either. But if I say 2.1, that works, okay? Because 2.1 is greater than 2. Let's see what else. There's also these recursive functions that kind of back up to a number. And I think maybe the best way to show that one is in Python Tutor. So this is the pythontutor.com. I'm going to go ahead and put this one in. So this says if x equals 0, return 4, otherwise return h of x minus 1 plus 3. So I want to just, first I want to do an example that works, just so we can do some looping through. So I'm going to close off for now, and in the next video I'm going to start up with this one.